expected value. So if I have a random variable x as a function of x, let's call it phi of x, and I have the probability of x, probability mass function of x, p of x, then the expected value of phi of x is, and I write it big E, square brackets, phi of x is equal to the sum over all possible values of x of phi of x, p of x. So this basically gives you, we call it expected value, but really what it is the average of this function over x. Two very important instances of the expected value are mean and variance. So in mean, it's phi of x is just equal to x. So we have the expected value of x is just the sum over all x of x dx. So if you like, the values of the random variable are sort of centered around this value. This is the central value. Variance, let's call this mx, or mean of x. So variance phi of x is now equal to x minus mx squared. And let's give this the symbol, for complicated reasons, we call this sigma squared x. This is equal to the expected value of x minus mx squared, which is the sum over x of x minus mx squared dx. The interpretation of variance, basically I'm subtracting out the means, I'm subtracting out sort of the central value. So this is how much does the function deviate from its central value on average. It's squared because we need it to be positive. So if I was just taking the expected value of x minus mx, that actually is 0. So what I want to know is how far does it deviate, and I want to accumulate it on either side of the deviation. If you happen to know the expected value of x squared, then there's an easy way to calculate variance. First, let me say a few properties of expectation. Expected value of a plus b is equal to the expected value of a plus the expected value of b. For a scalar, what I mean by scalar is deterministic, non-random. For a scalar value, let's call it u, and random x, expected value of ux is equal to u times the expected value of x. Similarly, for any scalar u, the expected value of u is just u. Because it doesn't change, it's natural that the average of something that doesn't change is just itself. And finally, if A and B are independent, then the expected value of A times B is equal to the expected value of A times the expected value of B. And if and only if they're independent. If they're not independent, then that doesn't work. And in fact, if they're not independent, there's no shortcut. You have to do the hard work yourself. In each of these cases, it's not too hard to show this by substituting it into the sum form, the sum equation of expectation. But I'll let you do that on your own if you're so interested. Okay, so coming back here, there's another way to write variance. So variance sigma squared of x is the expected value of x minus mx squared. So if I expand what's under the expectation, then I have x squared minus 2mx x plus mx squared. By the first property, I can write this as the expected value of x squared minus the expected value of 2mx x plus the expected value of mx squared. Okay, what can I do here?
Take the 2 out.
I'm going to take the 2 out. What else can I take out?
And also
mx. Mx is a scalar, so mx is deterministic. It's not random anymore because it's the particular value, which is the average of x. So that's not random. X, however, is still random. So I can take out both 2 and mx. I can't do anything with x squared. What can I do with this?
That's mx squared.
That's just mx squared because mx is a scalar, so mx squared is a scalar. What's the expected value of x?
X dx.
Yeah, but is there another symbol that I can give to that?
2mx or just ex?
To ex.
Ex is just...
It's just mx, right?
Yeah.
So ex, expected value of x is just mx. So this is expected value of x squared minus 2 mx squared plus mx squared, which is equal to the expected value of x squared minus mx squared. So if you happen to know, two things to notice here. If you happen to know the expected value of x squared, but you don't know the variance, you can quickly get it. Secondly, if the mean is 0, if the mean of your random variable is 0, then the variance is equal to the expected value of x squared. Okay, any questions on discrete value random variables? So I'm hoping this is review to you. Which is why I'm going quickly.